Hello and welcome to another episode of Interactive Biology TV, where we're making biology fun. My name is Leslie Samuel, and in this episode, episode 48, I'm going to show you how to read an electrocardiogram. For short, it's called ECG or EKG. So let's get right into it. First, I want to answer the question, what is an electrocardiogram? An electrocardiogram is a test that records the electrical activity of the heart. We looked at how the SA node starts the signal, and we looked at how that signal spreads to the rest of the heart. And you can always go back to episode 46 for more details on how that works. Now, the ECG is used to test for irregularities in how the heart functions. And you've probably either seen this firsthand in a hospital or on TV. You can look at the electrocardiogram and it will tell you if the heart is working the way it should. The way this is conducted is by placing skin electrodes on different parts of the body, and these electrodes are able to detect the electrical activity of the heart. And when you look at an electrocardiogram, it looks kind of like this. And you've probably seen this. Normally when you see this, there's a beep associated with it, and there's no beep in this animation, but you get the point. Now what we're going to do is we're going to look at this, and we're going to look at each component of the electrocardiogram. So let's look at it right now. So we're looking at an electrocardiogram, and you can see that we have a number of things. We have this peak over here, and we're going to call this the P wave, this peak right here. And then we have this section that we're going to call the QRS complex. And then we have the T wave, and sometimes we get this U wave, and we're going to talk about what these different waves show. So the P wave, we've looked at how the SA node generates the signal, and then that signal spreads to the muscle cells in the atria. And what this P wave shows us is the depolarization of the atria. Okay, so when the atria depolarizes, we see this peak. Then we have the QRS complex, and you probably guessed it by now, but this shows the depolarization. The depolarization of the ventricles. That is what is represented by the QRS complex. Then we have the T wave, which comes after the QRS complex, and this shows the repolarization of the ventricles. Now you're probably wondering why the signals that come from the ventricles are significantly larger than this little signal that comes from the atria. But if you look at the heart, you'll see that the atria is significantly smaller than the ventricles. So when the cells in the ventricles depolarize, that's going to have a much greater effect on the EKG or the ECG, because you have more cells depolarizing, so you get a stronger signal. And then of course you get the repolarization. Now the U wave is one that you don't always see. It's sometimes hard to see, and in most cases you don't really see it, but in some cases you do see it, and in some cases it can tell you something about when things are going wrong with the heart. We're not going to go into all those details, but I included it here because it was shown in this picture that I found, and because it does show up sometimes. And some people think that it's the repolarization of the Purkinje fibers. And it's also thought to be the repolarization of some other specialized muscle cells, but we're not going to go into that. The main things are the P wave, the QRS complex, and the T wave. The P wave being the depolarization of the atria, the QRS complex being the depolarization of the ventricles, and the T wave being the repolarization of the ventricles. If you ever need a refresher on what the terms depolarization and repolarization mean, you can always go back to episodes 9 and 10, and that will give you more details. Well, that's all for this video. As usual, I'd like to invite you to check out the website at interactive-biology.com for more biology videos and other resources to help make biology fun. This is Leslie Samuel. That's it for this video, and I'll see you in the next one.